You know, there's this one number that, believe it or not, pretty much controls the price of everything you buy. Seriously, that new gadget, the car in your driveway, even that Amazon package that lands on your doorstep. Its final price tag can be traced back to this one single figure.
And that number? It's the cost per hour of human labor. It's like the fundamental building block of our whole economy. But what if that foundation, that core number, is about to change more dramatically than it ever has in our lifetimes? So right now, here in the US, that number is about $46 an hour. And look, that's not just what someone takes home in their paycheck. This is the fully loaded cost. We're talking health insurance, retirement, payroll taxes, the whole shebang. If you're running a business, this is your baseline for getting 1 hour of work done by a person.
So here's the multi-trillion-dollar question. What happens to, well, to everything when that $46 cost absolutely plummets by 96%? And this isn't some sci-fi fantasy anymore. This is exactly what Tesla's Optimus robot is being designed to do.
I mean, just look at the sheer scale of this disruption. We are not talking about a little 10 or 20% improvement here. We are talking about going from $46 an hour for a person down to less than $2 an hour for a humanoid robot. This isn't just a big bet. It's the biggest bet in industrial history.
All right, so how on earth is a number that low even possible? I know, it sounds completely made up, but the math is actually surprisingly simple. So let's just break it down.
Okay, it really boils down to 4 things. First up, the sticker price. Tesla's aiming for about $25,000 per robot once they're at scale. Next, the hours. A person works, 2,000 hours a year? A robot doesn't need sleep, doesn't take vacations, so it can run for over 7,000 hours. Then you've got your overheads, which are tiny. We're talking pennies per hour for electricity and upkeep. And then here's the kicker, the savings. You get rid of all those human-related costs, no insurance, no HR department, no payroll taxes. You add all that up, and you land under $2 an hour.
The bottom line? You're looking at a 96% cost reduction in the most fundamental input of our entire economy, labor. And the implications are just staggering. But to really get what happens next, we actually need to take a look back in time.
Now, I know the first thought everyone has is, oh no, mass unemployment, right? If a robot is 96% cheaper, what happens to all the human jobs? Well, we've seen this movie before, and trust me, it has a surprise ending.
It all centers on this idea called Jevons paradox. The core concept is actually pretty simple. When you make something radically cheaper and way more efficient, we don't just use less of it. We end up using way more of it because we find all these crazy new things to do with it.
The perfect example is the power loom. Back in 1810, weavers were these highly skilled artisans. Then the power loom shows up and suddenly one person could do the work of 10. The weavers, of course, thought it was the end of the world. But what actually happened? The price of cloth just collapsed. And the effect? Suddenly, everyone could afford way more clothes. Entirely new industries like ready-made fashion just popped into existence. And get this, within 50 years, there were more people working in textiles than before the machine was even invented.
And you see this pattern repeat over and over again. More efficient steam engines didn't save coal, they powered an entire industrial revolution that burned more coal than ever. Cheaper computer chips didn't mean we bought fewer computers. It meant we put them in everything, from our cars to our toasters. Cheaper data storage, that's how we got YouTube and TikTok. Radical efficiency doesn't kill demand. It creates an explosion of new demand.
But Jevons paradox, that's only half the story. The push for humanoid robots isn't just about making things cheaper. It's actually about a much deeper, much more urgent problem. We are, quite literally, running out of people.
Just take a look at this. The US recently hit its lowest birth rate in recorded history, 1.6 children per woman. Now, the replacement rate, that's the number you need just to keep the population from shrinking, is 2.1. We are just not producing enough future workers to keep our economy going as is.
And hey, this isn't just a US problem. It is a full-blown global crisis. South Korea's birth rate is an absolutely shocking 0.72. China's workforce has already been shrinking for over a decade. The entire developed world is staring right off a demographic cliff. The workers we're going to need in 2045, they were simply never born.
So here's the crucial takeaway. When you're facing a massive worldwide labor shortage, this problem stops being about cost. It becomes about necessity. You literally cannot manufacture a 25-year-old human, but you can manufacture a robot.
Okay, so if this demographic cliff means we need robots,
The next logical question is, who's going to build them? And yeah, you've got companies like Boston Dynamics and Figure AI in the race, but Tesla has an advantage that almost no other company on the planet has.
It's called full vertical integration. And what that really means is they control every single piece of the puzzle. They design their own AI chips, from the silicon up. They write their own software. They train that AI on real-world vision data coming from millions of their cars already on the road. And, maybe most importantly, they already know how to bend the metal, build the motors, and manufacture millions of incredibly complex machines every year. They own the whole process, start to finish.
And that is the key difference. All their competitors have to buy chips from one company, license software from another, and then try to find a third company to manufacture for them. Every one of those steps adds cost, adds delays. Tesla controls the full stack, from the chip to the factory floor. It's all them.
So, where does all this leave us? Well, the opportunity is clearly beyond massive, but let's be honest with ourselves. This transition is going to be messy.
Let's just have a quick reality check. No, Optimus is not going to be folding your laundry next year. It's still deep in R&D. And yes, when this tech really hits its stride, the economic pressure on jobs in sectors like trucking and warehousing is going to be immense. And unlike the Industrial Revolution, which took generations to unfold, this is going to happen in like a decade. It's going to be fast.
But the underlying truth, the fundamental economic shift, remains the same. The cost of labor, the very foundation of our economy, is on the verge of dropping by over 95%. And if Jevons' paradox holds true, the total amount of work getting done in the world isn't going to shrink. It's going to absolutely explode, creating whole new industries that right now we can't even begin to imagine.
Think about it. Those hand weavers back in 1810, they looked at the power loom and they saw the end of their world, the end of civilization as they knew it. But what they were actually seeing was the painful, messy birth of the modern world. So the question for us right now is this: are we just seeing the end of one way of doing things, or are we actually witnessing the very beginning of the next one?